Hello friends, today we are going to discuss about transfer function determination using signal flow graph. This actually comes after the block diagram reduction techniques or block diagram reduction procedure, and signal flow graph is nothing. It is quite similar as that, quite similar. Like from a block diagram representation, you can also transform it into a signal flow graph. Signal flow graph is actually a graphical representation of any signal loop or signal flow. There can be the flow of input to output signal and also some feedback signal flow, and this way by nodes and the arrow mark of signal flow and the gain, these signal flow graphs are represented. So let me discuss all the points one by one, how it is represented actually. Let us take an example. If there is an input RS and the system gain GS and the output CS, its equivalent or corresponding signal flow graph will look like RS will be here, the signal will flow this side, the output will be here, and there will be a system gain, that is GS. We can represent it with only G here for the sake of simplicity, and here we used two nodes, and in between that I declared the gain value. Actually in this process all takeoff points and the summing points, means the adders, are transformed into nodes, and from there the takeoff and the gain values are taken. This will be more clear in my next example, and that is I am here taking the example of a loop feedback. We can say feedback loop or feedback. That will be loop in case of signal flow graph, and here it is actually feedback. Here is system gain, here is the unity feedback, this is negative feedback I have taken, and output is CS. Its corresponding signal flow graph will be as below, and that will be RS. For the summing point there will be a node, for the takeoff point there will be a node, in between that there will be the gain G, forward path gain, there will be the output CS, or you can say it as C. There is the feedback, and feedback is taken like this, and feedback is represented by this arrow, that is the reverse path. And as there is negative feedback and the feedback gain is 1, this will be represented as -1 gain, and this is the corresponding signal flow graph of this block diagram. Now let me take another example, and here I am just changing the value of feedback gain. I am just changing the value. As more you practice, it will be easier for you to understand. Here the value of feedback is HS, hence the corresponding signal flow graph will look like this. Here will be two nodes as before, here will be the gain G, forward path gain, and for negative feedback and the feedback gain H, here will be feedback gain H, and it will represent like this. You have to remember this. If there is positive feedback, means here it is positive, then this will become plus h or only h. Some points are now very important in this signal flow graph, and you always have to remember those points. And those are, there are actually three types of nodes. One is input node, one is output node, and another kind of node is mixed node. If any signal is going from a node, here it is output node, and if any signal is coming to that node, it will be acting as input node, means this is actually an input node, right? And now here I have drawn output and input all together, means it is acting as mixed node. And this can be like this also, here an output, here an input is coming, hence this is mixed node. Means there are three types of nodes. One is input node, second one is output node, and third one is mixed node. Now the main thing here, that is loop. In case of signal flow graph, you always have to differentiate between path and loop, right? So in case of loop, what is loop? Let us consider this example. Here the signal is generating from here, and by a feedback path this is ending here, means it is completing a whole loop, means we can consider it as a loop. Now if there is the signal like this is coming here, here is a node, here is a node, and here is a node. Now here the feedback is coming, or a signal is coming, then this loop is not completing actually. Means if you go this side, the signal flow is in the opposite side, means the loop is not completing. If the arrow is in the forward direction, means in this direction, then it will be a closed loop and it will be considered as a loop. This is the very important point. Now the advantage of signal flow graph over the block diagram reduction technique is that by Mason's gain formula we can directly and quickly find out the transfer function of any kind of system, and we can compare the stability or discuss about the stability factors, criteria of the system through the transfer function and the characteristic equation I have discussed before. So this Mason's gain formula helps us to find out the transfer function very quickly from the signal flow graph. Now the formula is actually like this: transfer function is equal to summation k pk delta k by delta. Now this seems tough to you, but this is a very easy and very useful formula. I am explaining each and every term right now, hence it will become very easy to you. First of all, what is k? K is the number of forward path. number of forward path. Now if you don't understand this forward path conception, I'll discuss it in my example video where I'll discuss the whole problem about this, and each and every point will be clear then. Still, you understand the points, you remember these names, and the functionality will be discussed later on and it will be more clear to you. Now k is the number of forward path and pk is forward path gain of kth path. Forward path gain of kth path means this is actually the gain. Now the very important, that is delta. What is delta? Delta is actually called signal flow graph determinant or characteristic function. Signal flow graph determinant or characteristic function. Now, how it is calculated? It's calculated by a simple formula, that is 1 minus sum of individual loop gain, sum of individual loop gain plus, first minus then plus, it will be alternating actually, sum of individual loop gain will be calculated and the summation will be taken and that will be subtracted from 1 minus sum of individual loop gain means you have to check how many loops are there in that signal flow graph, plus sum of product. I think you have practiced SOP formats in various cases and various subjects. The same thing is here, sum of product of all possible two non-touching loops, two non-touching loops means the sum of product of all possible non-touching loop means in a signal flow graph if there is two non-touching loop means no nodes are there common, though their gains will be multiplied and then the pairs means the multiplied result of those pairs will be summed up. The sum of product of all possible two non-touching loops and minus plus after that minus sum of product of all three non-touching loops. If you understood this concept, means two non-touching loops, you can easily understand three non-touching loops. When three loops will not touch each other, then that will be the total multiplied gain values, means we have to calculate the total multiplied gain values of that, and we have to find out how many these kind of cases are there, and we have to take the summation. If you don't understand these points, I think these terms are very tough to understand by reading at first time. If you see an example, these things will be very clear to you, and by this alternating thing will repeat, means after that 4 non-touching loop, 5 non-touching loop, this will come. This is actually all about Mason's gain formula. But one thing is left, many students have doubt about it, that is delta k. What is it actually? Delta k is actually the value of delta for the part of the graph not touching with kth forward path. With kth forward path means this is actually linked with the forward path, right? So this is actually not a very easy concept. You have to understand it only through an example, and after this lecture, in my first video or first example, I will discuss or clear this point. Means in my problem this part will be there, and it is very important to understand. Now there are actually 4 types of problems which come from the signal flow graph, and in my next 4 example videos I will explain these all 4 types, and all types will be very clear to you. So thank you. If you like the video, please subscribe and like the video and press the bell icon. If I upload any important video after this, and it will be very helpful to you, you will get the notification and you can study accordingly and take notes, and it will be very useful for you for your university examination as well as GATE examination. Thank you.